Welcome. In this video we are going to discuss the star connected and delta connected problems. So first consider a star connected system. So before starting the problem you have to remember some points on star connection. In a star connection the line voltage VL equal to root 3 times of phase voltage. The line current IL equal to the phase current I phase. The power equation P equal to root 3 VL IL cos phi. So all these equations we are using in the problems. So let us consider the first problem. A balanced star connected load of 8 plus J6 ohm per phase is connected to a balanced 3 phase 400 volt supply. Find the line current, power factor, power and total volt ampere. So here given data is the star connected load. The load details is given 8 plus J6. It is in the rectangular format. So 8 plus, the plus sign indicates it is a R plus XL format. So the R equal to the 8 is a resistance, that is 8 ohm is a resistance, and plus J6, that is XL value is 6 ohm. So this is a per phase value. So in the figure all the three phases are shown. So first phase 8 plus J6, the second phase 8 plus J6, third phase also 8 plus J6. So while calculating we are using the per phase values for easy calculation. So first we are going to find the per phase impedance, that is Z phase. So Z phase equal to root of R square plus XL square. So here R is 8 ohm and XL is 6. So root of 8 square plus 6 square. The answer is 10 ohm. There is a impedance of the per phase. Each phase has 10 ohm impedance. All are balanced connection. So all the phases has same impedance 10 ohm. Now we know that the line current, the line voltage is given, that is 400 volt. So we can convert it into phase voltage. So V phase equal to VL by root 3, that is 400 by root 3. The answer is 231 volt. All the values here rounded. So 231 volt. Next I phase equal to the phase voltage divided by phase impedance, V by Z. So here we is using phase values. So I phase equal to V phase by Z phase. So V phase we calculated, that is 231 divided by Z phase is 10 ohm. So 231 divided by 10. The answer is 23.1. That is a I phase. So in a star connection the line current equal to phase current. So line current equal to phase current, that is 23.1 ampere. That is the first answer. Next is power factor. Power factor also calculating for per phase only. So power factor cos phi equal to R by Z. So here R by Z means R phase, the phase value of R divided by impedance of the phase. So R phase by Z phase, that is 8 is a R phase and Z is 10. So 8 by 10 is 0.8 lag. Power factor is 0.8 lag. Why it is lagging means it is a RL load. 8 plus J6, the plus indicates that is a R plus XLJ, that is a inductive load. So it is lagging. Next is power. Power P equal to, the equation is root 3 VL IL cos phi. Root 3 VL value is 400, IL is 23.1 and cos phi is 0.8. So while multiplying we will get 12,800 watts. So in a RL circuits the power dissipates in resistance only. The pure inductor has 0 power. So in the 3-phase circuit also, so 8 plus J6 in 3 phases, here power dissipates in the resistance only. The coil has, or coil dissipates 0 power. So we can calculate the power in alternate method. So in the next line given, the power equal to 3 into I phase square R phase, or I square R. I square R means only one phase we can calculate I square R. So multiplying by 3 means it goes to 3 phase. So 3 into I square R, 3 into here I phase is 23.1 square into R value is 8. So 3 into 23.1 square into 8 is the answer is same answer, that is 12,800 watts or 12.8 kW. Next is total volt ampere or apparent power. Apparent power equation is S equal to root 3 VL IL. So root 3 into VL is 400 and IL is 23.1. So while multiplying we will get 16,000 volt ampere or 16 kVA. Second problem, the problem is given 3 equal star connected inductors take 8 kW at a power factor 0.8 when connected across a 460 volt 3 phase 3 wire supply. Find the circuit constants of the load per phase. So circuit constants means its resistance value and the inductance value etc. is the circuit constants. So we are going to find the circuit constants. The given data, the power dissipates in the 3 phase star connected is given, that is 8 kW or 8000 watts. 8 into k means 10 to the power 3. So 8 into 10 to the power 3 means 8000. So 8000 watts or 8 kW. So we know that power equation P equal to root 3 VL IL cos phi. From this equation the power we know, VL given 460 volt and power factor also given 0.8, only IL is the unknown. So from this equation we can calculate the unknown value IL, the line current IL. So 8000 equal to root 3 into 460 into IL into 0.8. So while taking IL outside, IL equal to 8000 divided by root 3 into 460 into 0.8. We will get the answer IL equal to 12.55 ampere. It's a star connected load. So line current equal to phase current. So phase current also I phase equal to 12.55 ampere. So from this value we can find out the I phase, and using I phase and V phase we can find out Z phase. Before that we have to find the V phase. So phase voltage equal to line voltage by root 3. Line voltage is 460. So 460 divided by root 3 we will get 265 volt. That is a phase voltage. So we know that I phase equation, I phase equal to V phase by Z phase. From this equation we can find the Z phase. So denominator Z phase comes to numerator and the I phase numerator goes to denominator. So Z phase equal to V phase by I phase. So V phase is we calculated, so 265 and the I phase is 12.55. So while doing the calculation, 265 divided by 12.55 we will get 21.1 ohm, that is a Z phase. Once we got the Z phase value, next we can calculate the R value and the X value or XL value by using impedance triangle. Impedance triangle is a right angle triangle. The adjacent side is a R, opposite side is a XL and the hypotenuse is Z. So using that triangle, the R value or here R phase value equal to Z phase into cos phi. Here R is a adjacent side or cos component. So Z phase into cos phi. Cos phi values already we know. So 21.1 into 0.8 we got 16.9 ohm, that is a R value. Resistance is 16.9 ohm. Similarly the XL value or X phase equal to Z phase into sin phi, opposite side. So 21.1 into 0.6 equal to So 0.6 is comes from, we know the cos phi value, so cos phi is 0.8, so phi equal to cos inverse 0.8, so we'll get the phi value, that phi insert into sin phi, so sin phi becomes 0.6, so Z phase or X phase equal to 12.66 ohm. Here one small problem is given. Given a balanced 3-phase 3-wire system with star connected or Y connected load, for which line voltage is 230 volt and impedance of each phase is 6 plus j8 ohm. Find the line current and power absorbed by each phase. So per phase impedance is given, that is Z equal to 6 plus j8. So Z phase equal to, here 6 is the resistance R and 8 is the XL. So Z phase equal to root of 6 square plus 8 square, that is answer is 10 ohm. The line voltage is given, that is 230 volt. So V phase equal to VL by root 3. So VL is 230. So 230 divided by root 3. Answer is 133 volt. All the values are rounded. Next, power factor. Power factor cos phi equal to R by Z. R is 6 ohm. Z is calculated 10 ohm. So 6 by 10, that is 0.6 is a power factor. Next, I phase equal to V phase divided by Z phase. V phase calculated 133 and the Z phase is calculated, that is 10 ohm. So 133 divided by 10, answer is 13.3 ampere. So our first answer, line current. So line current equal to phase current in a star connection. So IL equal to I phase, that is equal to 13.3 ampere. That is the first answer. Next is power absorbed by each phase, that is equal to I square R. So here the power absorbed by each phase, not complete power, not complete 3-phase power, only per phase power is asked. So per phase power we know that is a I square R. In a RL circuit, only power dissipates in resistance only. The pure inductor has 0 power dissipation. So here also I square R equation is enough. So I square R, I equal to 13.3 square into R is 6. So answer is 1061 watts or 1.061 kW. That is a power absorbed by phase. Next problem. When the 3 identical star connected coils are supplied with 440 volt 50 Hz 3-phase supply, the single phase wattmeter whose current coil is connected in line R and pressure coil across the phase R and neutral reads 6 kW and the ammeter connected in R phase reads 30 ampere. Assuming RYB phase sequence, find the first one, resistance and reactance of the coil, second one, the power factor of the load, third one, reactive power of 3-phase load. In this problem, the given figure is not matching the question, the figure is changed. So just consider the questions. Here a 3 identical coils, that means its load, 3 coils are connected in star. The supply is given 440 volt, that is line voltage, 50 Hz 3-phase supply, and a wattmeter connected across R phase and the neutral. So R phase and neutral, that means a single phase supply, that is R and neutral means single phase supply. So wattmeter is connected across a single phase, that is R phase. So it reads only phase values. So phase values means it gives only phase power. So the reads 6 kW means 6000 watts only for per phase value. So one phase is consumes 6000 watts. Here balanced means all the phases same power dissipates. So here the given 6000 watts, that is VL, not VL, VI cos phi equal to 6000. So here V and I means V phase, I phase, cos phi. So V phase, I phase, cos phi equal to 6000. So from this equation V phase is we can calculate by using VL. So V phase equal to VL by root 3. VL is given 440 volt. 440 divided by root 3 means V phase, that is 254, and I phase also in the given the reads 30 ampere. Ammeter connected in R phase reads 30 ampere means that is IL, that is IL equal to I phase in star connection. So I phase equal to 30 ampere. So 254 into 30 into cos phi equal to 6000. From this equation cos phi equal to 6000 divided by 254 into 30. We got cos phi equal to 0.787. That is a cos phi or power factor 0.787. So from this equation we can find the phi also. Phi equal to cos inverse 0.787. We got phi equal to 38.06. So using this value, sin phi equal to sin 38.06 equal to 0.616. It's a sin phi value. So next Z phase equal to V phase by I phase. V phase we calculated 254 and the I phase is given, that is 30 ampere. So 254 divided by 30, the answer is 8.47 ohm. That is a Z phase value. Once we got the Z phase value, next we can calculate the R and XL value by using the impedance triangle. So here R value is the cos component. So R equal to Z phase into cos phi. Z phase is 8.47 into cos phi is 0.787, that is 6.66 is the resistance value. Next XL value, that is a opposite side or sine component, that is Z phase into sin phi. That is equal to 8.47 into 0.616, that is 5.22 ohm. That is a resistance and the reactance of the coil. The first answer is our resistance is 6.66 and the reactance XL is 5.22 ohm. Second one is power factor. Power factor already we calculated, that means power factor equal to cos phi. Cos phi equal to 0.787 lagging. Why lagging means it is a RL circuit, so it is lagging. Third one is reactive power of three phase load. So reactive power equation root 3 VL sin phi. Here the phi is erased. So root 3 VL IL sin phi. The sin phi value also we calculated, that is 0.616. So reactive power equal to root 3 into VL is 440 into IL is 30 into 0.616. We will get 14,083 volt ampere or 14.083 kVA. That is a reactive power, but here unit is mistaken. Take unit is kVAR. One R is added here. Reactive power always written in kVAR, kilovolt ampere reactive. So just correct it, 14.083 kVAR. That is the answer. Now consider delta connected loads. Before that we have to remember some points on delta connection. So in the delta connection, VL or line voltage equal to phase voltage, VL equal to V phase, and the current IL equal to root 3 times of I phase. The power is same as the star connection, power equal to root 3 VL IL cos phi. So these 3 points always remember. So in this problem, a star connected alternator supplies a delta connected load. The impedance of the load branch is 8 plus j6 ohm per phase. The line voltage is 230 volt. Determine first one current in the load branch, second one power consumed by the load, third one power factor of the load, fourth one reactive power of the load. So here star connected alternator supplies delta connected load. So we are calculating everything on delta connected load. So just forget the star connection, supply side. Only delta connected load we are going to discuss. So in the delta connected load, VL equal to V phase, IL equal to root 3 times of I phase, and power equal to root 3 VL IL cos phi. So considering the delta connected load, we have Z phase. The each branch impedance is given 8 plus j6. So 8 plus j6 in the form of rectangular form R plus jXL. So it's a RL circuit each branch. So Z phase equal to root of 8 square plus 6 square. Answer is 10 ohm. And V phase equal to VL, that is given 230 volt. So Z phase equal to 10 ohm, V phase equal to 230 volt. So from this value we can calculate the first one, current in the load branch. That means each phase values. So I phase equal to V phase by Z phase. V phase 230 volt, Z phase is 10. So 230 divided by 10 is 23 ampere. Next, it is a phase current 23 ampere. Next we are calculating the line current. Line current IL equal to root 3 times of I phase, that is root 3 into 23, that is 39.8 ampere. That is the second answer, line current. So power, next is power consumed by the load. Power equal to root 3 VL IL cos phi. So here cos phi value we have to calculate. So cos phi means R by Z, power factor cos phi equal to R by Z. Here R is a 8, Z is 10. So 8 by 10 is a 0.8 lagging. So lagging means it's a RL circuit. So 0.8 lagging is a power factor. So power equal to root 3 VL IL cos phi. Root 3 into VL is 230, IL is 39.8 ampere into cos phi is 0.8. So while doing the multiplication we will get 12,684 watts or 12.684 kW. Next, last one is the reactive power. The power factor is already we discussed. The reactive power Q equal to root 3 VL IL sin phi. So root 3 VL IL sin phi. Sin phi we got from cos phi. Cos phi equal to 0.8. So phi equal to cos inverse 0.8. We will get the phi value. So that phi is a sin phi. The phi value should be 0.6. So root 3 into 230 into 39.8 into 0.6. The answer is 9,513 not watts here. VAR, volt ampere reactive, or 9.513 kVAR. Next problem. A delta connected balanced 3-phase load is supplied from a 3-phase 400 volt supply. The line current is 20 ampere and the power taken by the load is 10,000 watts. Find first one, impedance in each branch, second one, the line current, power factor and power consumed if the same load is connected in star. So in this problem, first we are calculating in delta connection. Next, in the second part we are calculating the power consumed in the same load connected in star. So first is delta connected. Here in the delta connected, V phase equal to VL, that is 400 volt, and IL equal to 20 ampere. The line current is 20 ampere. This is given data. IL equal to 20 ampere. So I phase equal to IL by root 3. That is 20 by root 3 is 11.54 ampere. And Z phase equal to V phase by I phase, that is 400. V phase equal to 400 and the I phase equal to 11.54. The answer is 34.64 ohm. That is a Z phase. And the power in delta connection, P equal to root 3 VL IL cos phi. So from this equation, phi we can calculate. Phi equal to, power is 10,000 watts, so 10,000 equal to root 3 VL IL cos phi. So from this equation, cos phi equal to 10,000 divided by root 3 into 400 into 20. Here 20 is a IL, equal to 0.7217. That is a power factor. Power factor equal to 0.7217. Next, the load is connected in star. So now the values are changing. So V phase equal to VL by root 3. So VL is given, the line voltage is 400. So 400 by root 3 means 230.94. That is a V phase value. So I phase equal to V phase by Z phase. Z phase already calculated. So V phase 230.94 divided by 34.64. So 6.67 is a I phase. In the star connection, IL equal to I phase. So IL equal to 6.67 ampere. The power factor remains same since impedance is the same. So Z phase is same in delta and star connection here. So power factor also remains same. So power consumed in the delta connection, not delta, star connection is root 3 VL IL cos phi. So root 3 into 400 into 6.67 into 0.7217. The answer is 3330 watts or 3.33 kW.